Lesson 1013, Areas of Regular Polygons. Before we get started, here's a quick look at our special right triangles. In the first picture, we have a 30, 60, 90. Opposite of 30 is 1. Opposite of 60, the ratio is root of 3. Opposite of 90 is double. A 45, 45, 90 triangle. Opposite of 45 is 1. Opposite of 45 is 1. Opposite of 90 is square root of 2. These will come in very handy in this lesson. The area of a regular polygon is related to the distance from the center to a side. And that distance is called the apothem. So that's this orange length. You can circumscribe a circle about any regular polygon. So that means you can put a circle outside of it. The center of a regular polygon then becomes the center of the circumscribed circle. That means that we can find a radius. And that radius would be the distance, any of these blue distance, from center to the edge of the circle. So I will color it green. So the green would be considered a radius. This would be a radius. So any of those blue lines is a radius. And the apothem is the perpendicular distance from the center to a side. So to find the area of our polygons today, for example, here is a pentagon, we would need to find the measure of angle 1, angle 2, and angle 3. The figure at the right is a regular pentagon with radii and apothem drawn. What is the measure of each numbered angle? So remember, our pentagon can be circumscribed inside that circle. So then what happens is the distance from here to here would be our radius. So the orange is our apothem, and these blue dotted lines are our radii. So then what we need to do is find a central angle. So a central angle is going to be the measure of an angle from here to here. And that's what the measure of angle 1 is. So if I start here and I go all the way around, how many degrees would that be? So again, from here all the way around to here, that would be 360 degrees. To figure out what one of those sections would be, I would split it up into 5 equal sections because there is 1, 2, 3, 4, 5 of those angles in there. So 360 degrees divided by number of sides. If there are 5 sides on a pentagon, then it would have 5 central angles. That is going to give us 72. So to find a central angle, our formula is to take 360 divided by the number of sides. So angle 1 was a central angle. Then the relationship with angle 2 is it splits that central angle in half. So what we're going to do is we're going to take that 72 degrees and divide it by 2 for 36. So then what happens is this triangle that we're trying to find the measure of angle 3 in, I can kind of turn it so that this side would be the apothem, this orange side here, and I need to find the measure of angle 3. So I have a right triangle, and I just found out that angle 2 is 36. So then what I can do is think, what does the whole triangle add up to? Well, 180. So if I have 180 degrees in there, I know that this angle is 90, this angle is 36. So I already know that this is 90, so then I know that 36 and this angle 3 have to add up to another 90 to make 180. So I'm going to do 90 minus 36 to get that third angle, which is a 54. So let's try that again. At the right, a portion of a regular octagon has radii and apothem drawn. Our apothem goes to the middle of a side, and our radius goes to a vertex on the polygon. So the blue is a radii, and the orange is the apothem. What is the measure of each numbered angle? So we have to first find our central angle, and that's what the measure of angle 1 is. So they told us this is an octagon. So an octagon has 8 sides, which means it's going to have 8 central angles. So we're going to do 360 divided by 8, which gives us 45. So that means that this angle is 45, this angle is 45, these two angles would be 45, and so on. So then to find the measure of angle 2, we would take that 45-degree central angle and divide it in half. So that angle is now 22.5 degrees. So we need to find this angle 3. So I highlighted this triangle. Well, if over here this is a 90-degree angle, that means that this is also going to be a 90-degree angle. And angle 2 was given to us as 22.5. So then triangle sum, well, if this is already 90, we have 90 left over for those two angles. So 90 minus 22.5 is 67.5. Postulate 110. If two figures are congruent, then their areas are equal. That should make sense. If we have two triangles that are the exact same size and shape, then they should have the same area. Here's the big formula we're going to use today. In a textbook, it says to use area is equal to 1/2 apothem times perimeter. And I think it's easier to break down what that perimeter is. A perimeter would be number of sides times side length. So again, A is apothem, N is number of sides, and S is side length. Before we get going, let's review special right triangles. 45, 45, 90 is 1 to 1 to square root of 2. A 30, 60, 90 is 1 to root of 3 to 2. So here's our first regular polygon. We are given an apothem of 4. We're going to use the formula 1/2 apothem times number of sides times side length. So let's figure out what we know so far. Alright, so here's what we need. This 4 is the apothem. The distance from here to here is our radius. I'll just put a little r there so we remember. So our apothem is already given to us at 4. How many sides does this polygon have? Well, 4. So that's going to be a 4. We need to figure out what the side length is. So we need to figure out what this is. Well, if the distance from here to here is 4, the distance from here to here is also going to be 4. So I would say that this whole side is an 8. So when I multiply all this out, half of 8 is 4, 4 cubed is 64. We could have done this without the formula as well. If we figured out this side was 8, we could use our special right triangle, figure out our central angle. 360 divided by number of sides is 90. So that means a central angle, for example, from here to here would be 90. So then half of that would be 45, which makes this a 45-degree triangle as well. So if these two angles are 45, what I did was I just redrew this triangle over here. The ratio would be 1 to 1 to square root of 2. So if this side were a 4, then the distance from purple to purple would also be 4. And because this triangle would be the exact same measures as this triangle, this is also 4. So there comes our other 8. And 8 times 8 is 64 as well. Number 2. This one isn't going to be as easy. So if we plug in our values, our apothem, again, is given to us at 4. And I'll try to make it more clear if the 4 is the radius or the apothem, but that's the apothem. I take that back. If I delete that yellow line, it looks like the 4 is the radius. So then when I draw in that yellow line, that's the apothem that we have to have for our formula. So in this case, our special right triangle is going to be very important. So if I redraw it, this is the 4, and here's the right angle. Our first step is to find that central angle. 360 divided by the number of sides. And if you count these, you should get 6. So that's going to give us a central angle of 60 degrees. So from there to there, the measure is 60. But again, if I draw in this radius, I only want half of that. So then half of that central angle is 30. And then my special right triangle becomes a 30, 60, 90. So my ratios, opposite of 30 is 1, opposite of 60 is square root of 3, and opposite of 90 is double. We need to figure out our missing sides. So we don't know what our apothem is. Our number of sides we just said was 6. Our goal is to figure out what this length is, which is right here, so that I can double it and get a whole side. So we're given the hypotenuse, and we need to go to this shortest leg, opposite the 30. So our ratio is 2 to 1. That ratio has to be the same for 4 to x, and that's that side that we're trying to find. So that turns out that this distance is going to be 2. So from here to here is 2, the other one is also 2, so our side length is going to be 4. Now the only thing left is our apothem. So if we know that the side with the 1 on it is 2, then to go over to the longer leg, I multiply by the root of 3. So that side is 2 roots of 3. So we multiply through on a calculator. Half of 2 is 1, 6 times 4 is 24, roots of 3. Question number 3. We have a pentagon. We're trying to find the area of it. So it looks like our apothem is given at 4. The number of sides is 5. So we have to figure out what the side length is. So this S is what is missing. So that would be the distance from here to here. So our goal is going to be to find half of it, which is going to be this length, and then we'll double it to get a whole side. So copying this information, we need to figure out our central information, our central angle. So this triangle I redrew over here. So our central angle is going to be found by doing 360 divided by the number of sides. So that would be 5, which gives us 72. So that tells us that our central angle, which would be from here to here, or from there to there, would be 72. So then if I drew that dotted line here, half of that 72 would be 36. So this is not a special right triangle, so we're going to have to use our trig. Our goal is to find this side. So we have this angle, and we have this side here as a 4, which is our apothem. So as far as our trig ratios go, we have so, ka, toa. Opposite of 36 is x, adjacent to 36 is 4. So it looks like we're going to do the tangent of 36 is equal to opposite x over adjacent 4. So to solve for x, we multiply these two. So 4 times the tangent of 36 would be approximately 2.9. So again, that length is for only half of it. So to get the whole side, we'd have to double. So 2.9 doubled is 5.8. So here's a cleaner look at that. So when I multiply through, I get approximately 58 units. Please pause the video and try number 4.